Alright, welcome grade 11 biology students. This is Mr. Brunet. So I'm going to run you through our first screencast, and I'm going to talk about how to use Excel to graph the information that's in front of you. So I'm using the sample data regarding the beak length of hummingbirds, and the idea here is because birds are evolved to their particular flower type and size, their beaks should vary in size. So that's kind of our hypothesis. Remember, the null hypothesis is that there is no significant difference between the two. And what that would mean is that evolution has not played a role in influencing the size of the beak of the hummingbirds. Okay, so here's our blank table here of data. Let me just delete this and show you how to do it. Most of you know how to take an average, but I'll just kind of run through this. So you just click on the cell, and you can either insert function, and then there's average. You highlight the information, and there it is above. It'll search for cells above. Then you can drag this over. So we now have our average. We want to now find out how much our values deviate from the, or vary from the mean. So we're going to go for standard deviation. So we click on a cell, and we're going to calculate standard deviation, which is SDEV. So in my, there it is right there, STDEV. So here's the standard deviation, and it's going to ask me to select the range. There it is. I can drag this over to the right again. Now we need to graph our information. So we're going to first by graphing the mean. So I select the mean, click on charts. I'm using a Mac, so it's going to vary where these buttons are, and then you look for the scatter graph. Now here's my scatter graph. I'm going to move this down. You can see our 2 points. We do not need the series label. Delete it. We don't need the x-axis label, so we delete it. So here are the 2 points. We now want to add our standard dev error bar to this. So I can double click it. On a Mac you have these options, and it's right there, error bar. Up here I'm on X versus Y, and I want the Y errors, which is vertical, these here. This is a fixed value. I can do %, standard dev. The best is to click on custom, and then you specify. We have a positive, so I click this. This will jump me into the data table. I will select 1.9 to 1.1, open that up, go for my negative values and use the same values. Open it back up and select OK. So there are my values. We now have a lot of wasted space down here, so I'm going to double click the y-axis, change the min to 14. The graph will expand. So what we're looking at now is if these error bars overlap. They do slightly overlap, but that's not significant enough to reject the null accepting the beak variation due to evolution. So we need to run a t-test. So I'm going to click on this box here by t-test, select my t-test, and we get array 1. Select in that box, choose your values, select array 2, choose those values, and typically it's a two-tailed test and it's type 2. And here's my value. Now what does this mean? In a t-test or in biology we're looking for 95% confidence. Therefore we're looking for a t-test value that is less than 0.05. This is quite significantly less than 0.05. Okay, so now we want to show this graphically. So we can calculate what is called a confidence norm, and that's going to be for us 95% confidence interval. So I click on this, look into my functions or my formula builder, and I find confidence norm. Click this. The alpha is 0.05. That's our value. Standard dev. We click this one. The size is the number of beaks for this one, which was 10. It's your sample size. Enter. And then like I did for the standard dev, I can drag this over, and we have two. Let me move this. I'm done with this formula builder. Close it out. Now I have these two values. So I'm going to once again graph the mean, which would look like this. I'll double click my point. Now remember, I'm using a Mac, so it's different in each computer program. So I click error bars. I'm going for the Y. I want to add both. I want to cap them. And I want to go to custom again, select special value. Under the positive, I'm going to select these two values right here. The program will automatically add these values to the appropriate point or mean value. And I do the same thing for the negative. Drag it over, open it up, and click OK. And we are finished. Now you can see there is no gap between the error bars. There's no overlap. Therefore, we can reject the null. And by rejecting the null, we're accepting our original hypothesis that the beak sizes are do vary in size because of evolution. They're adapted to their particular flower size. Okay, now this graph would receive 0 points because there's no labels and so on. So I'm going to quickly click on one that's already finished. Here's one that's already finished. Notice we have a Y label, and we have our uncertainty of plus or minus 0.01 millimeters. We have graph of raw measurements of beak length. Here's the scientific name. And we have error bars. Something else we could do is you could add you could label these. We can add data labels. It's going to add the value here. You can also then type in the bird associated with each mean value. That's just a little extra information. So this one here shows error bars that represent standard deviation. You must include in the title the fact that the error bars are standard deviation. And then here's one. Notice the overlap. Therefore, we have to continue further with our statistical analysis, and we did a t-test. The t-test was less than 0.05. Now we can show this graphically, and we did that by calculating the confidence norm. And this also is labeled error bars representing the 95% confidence interval. And now we see no overlap. Therefore, we reject the null. Alright, I hope this helps, and please go back and fix your graphs. They should be similar to these, however yours are going to be related to your leaf data. Alright, thank you for watching, and have a good day.